Welcome to homework.
We're given a relation R, which is the relation consisting of all pairs x and y, such that x and y are bit strings that agree in their first and third bits, and we're asked to show that this relation is an equivalence relation on the set of all bit strings of length 3 or more. So this is a subset of the set of all bit strings. First of all, let's define A to be the set of all bit strings with length at least 3. And then we have that R is, by definition, this is the set of all pairs x, y, such that all bits of x and y agree except maybe the first 3 bits So first of all, let's prove that it's reflexive. Let x be an element of A. Then we have that all bits of x and x agree, obviously. So it follows that x is related to x, and therefore R is reflexive. To prove symmetry, let x and y be an element of A such that x is related to y. This means that all bits of x and y agree, or, well, I should say except maybe the first 3 bits. And therefore it follows that all bits of y and x agree, except maybe the first 3 bits. And therefore we have that y is related to x, and so R is symmetric. Finally, to prove transitivity, let A, or x, y, and z be elements of A with x related to y and y related to z. It follows that all bits of x and y agree, except maybe the first 3 bits. Likewise, for y and z. Now, if all bits of x and y agree, except for maybe the first 3 bits, and all bits of y and z agree, except for maybe the first 3 bits, it follows that all bits of x and z agree, except for maybe the first 3 bits. So it follows that x is related to z, and therefore r is transitive. Now because r is symmetric, reflexive, and transitive, r is an equivalence relation.